Hi, welcome. I'm Professor G teaching you physics. Today I'll be talking about work and power. But before we begin, you know what to do. Subscribe to my channel and hit that bell icon for my upcoming video notifications. And let's begin. In this lecture, we're going to consider various forms of energy. But then first, let's consider a related concept called as work. Now, in daily terms, right, work is just the physical or mental exertion. But in physics, it's the transfer of energy. So there are two important factors that we consider whenever we look at work. It's the application of force and then the motion of an object due to this application of force. So work is actually defined as the product of force and then the distance that an object moves because of this force. So an equation form for work is force times the distance that the object moves. So W equals force times distance, right? Now we look at the units of work. Now work is defined as force times displacement. Force is measured, or in other words, SI units for force is Newton, right? And then distance is measured in meters. Hence Newton meter is the units for work. Okay, so let's look at some examples for work done. So if we lift an object 2-story high, then obviously the distance is doubled. So let's look at the figure here. So in this case, we have 1 story. The distance of 1 story is d as shown, and then you have 2-story. 2-storied building in this case, where you have distance, an object that can travel through is 2 times d, right? So now what happens to the work if we have to lift an object 2-story high, right? Of course, the distance is doubled, and then what we have is resulting with work twice as much, because of course the distance is twice as great. So let's look at this. What we know is W equals F times D. That's the definition of the work, correct? Force times distance. Now, if it is 2D times F, so what happens to work is, work is also doubled, or it's twice as much when the distance is twice as great. Now as a second example, let's look at what if we double the mass of the object. Now what happens to the work, right? So work is twice as much because of the force that's needed to lift the object is twice as much. Now we know work equals force times distance. So now let's say I have this particular object, right? And force in this case, or weight, equals mass times gravitational acceleration. Now if I increase the mass, that means twice the mass results with 2 times mg, resulting with weight which is 2 times weight, right? Now weight is nothing but the force applied, so I can bring this and substitute that in the place of force here. So that means 2 times mgd. Okay, so that results with twice as much work done on a given object, and that's how we see it. So whether we increase the mass or whether we increase the distance that the object moves, it brings up or it increases the work as well. Okay, third example is where I have a person, right, pushing on a wall. Now, for example, I have wall behind me. Now, let's say I try to push this wall. Do you think the wall is going to move? No, right? Now, this person may expend, right, his energy pushing on the wall, but the wall is not moving. That means there is no distance. Wall is not moving through any distance. Distance is actually 0. Now, let's bring that equation for work here. So, work is defined as force, applied force, times distance an object moves, correct? So now this person is actually exerting force on the wall, but the wall is not moving, so there is no work done on the wall. So distance is 0, right? Force times. So anything which is multiplied by 0 results with 0. Hence we say work done on the wall is 0. There is no work done on the wall because wall is not moving through any distance. Okay, so let's look at what work is needed to lift a bag that weighs 1000 Newton to a distance of 2 meters. Okay, so to answer this question, let's go back and bring our equation for work. Work done on an object equals force times distance that the object moves due to this force, correct? So we have F is given as 1000 newtons, and then we have distance which is equal to 2 meters. So we bring in and substitute that in the given equation. So that would be 1000 newtons times 2 meters. That results with 1000 times 2 is 2000 Newton times meter, and that's your SI units for work. So work is 2000 Newton meter, or this can be written as in terms of joules, 2000 joules. Okay, so next one is calculate the work if the bag that weighs 20 newtons is moved 3 times the distance of the previous problem. Okay, so previous problem distance was given as 2 meters, right? Now in this one it says 3 times the distance, so it's going to be 3 times d, resulting with 3 times 2 meters, right? So that would be 6 meters. So now we have distance which is equal to 6 meters, the new distance. So I'm going to call this as d with a subscript new. So that's our new distance for this problem. And then we have force which is given as 20 newtons. In order to find the work done on this given object, work equals force times distance. Force is 20 newtons times the new distance is what I'm talking about here. So the new distance is 6 meters. So 20 times 6 is 120 Newton meter, or this can also be written as 120 joules. So that's your work done on the given object. So next important concept in this lecture is power, right? Power is the measure of how fast work is done, or it's also defined as power is the amount of work, right, done per time it takes to do it. So work over time gives you power. As an equation form, work done over given time interval. So units would be, for work done is, of course we know it's Newton, Newton meter, and then time is measured in seconds, so that would be Newton meter per second, or joules per second, or we have a new term here, it's called as watts. So power is also measured in watts in honor of James Watt, 18th century developer of steam engine. So various forms of power would be P stands for power, right? So power equals work over time, or we can have the same equation in terms of time, which is T equals work over power here in second equation, and then the third one would be work equals power times T. Okay, so let's look at some examples. So let's say if a new forklift has twice the power than the old one, how much more load can it lift in the same amount of time? The answer is, of course, yes. Twice the power means twice the load, right? So that's the answer. And let's look at the second one. So if it lifts the same load as the old one, how much faster can it operate? Faster, right? Twice the load means twice as fast, or it can lift the same load in half time. Okay, so that's it for today, guys. So I'm going to see you in my next lecture next time. All right, then, bye.